Okay, section 1.2, now another definition. This is reduced row echelon form. And this definition, all of a sudden they start, it's really weird, they used I and double I for their ones and twos before. Now all of a sudden they're using a 1, 2, and 3. I'll go with it. Okay, so a matrix to be in reduced row echelon form. 1, well, it's row echelon to begin with. Okay, so we have all the 0 rows at the bottom, and the zeros at the left are increasing as we go down. And then 2, the leading entry, okay, the leading entry in a non-zero row. Okay, that's the leftmost non-zero term. Is 1. Okay, and then 3, all other elements, and we call that a leading column. So then all other elements of the column of a leading 1 are zeros. Well, zeros. Okay, so that's pretty simple, and that's my other dog waking up. So you could have something in reduced row echelon form might just look like this. Oops, there we go, there's a 1. There's a perfectly good reduced row echelon form. You could have something like this. So I've got 1, 0, 2, 3, 0, 1, 2, 5, and maybe 0, 0, 0. That's also reduced row echelon form. Okay, because the zeros are at the bottom, and the non-zero rows are moving to the right as far as their first non-zero entry. So that's our row echelon form. And then as I look at those non-zero rows, the first thing in each row is a 1. First non-zero thing in each row is a 1. And if I look at those columns, then, this column, just that 1 in all zeros, a 1 in all zeros. So that's reduced echelon form. Notice, the rest of this stuff over here doesn't matter. That could have been zeros. That could be anything. But those are, that's a reduced row echelon form. And now the reason we really like reduced row echelon form is, generally speaking, if this is part of an augmented matrix, it makes it very, very simple to come up with the answer that we were looking for. So, if, for instance, if I have this 1, 0, 2, 3, and 0, 1, 2, 5, 0, 0, 0, 0, and this was an augmented matrix, so this was, say, x1, x2, x3, and this was my B column, then you see what this says is x1 plus 2x3 is equal to 3, and x2 plus 2x 3 is equal to 5. And so I could tell you very quickly that x1 is equal to 3 minus 2x3, and x2 is equal to 5 minus 2x3. And so I know that then x3 is arbitrary. And just like that, I have a solution. So if I'm looking at this reduced row echelon form of an augmented matrix, then right there I can read off the answer very quickly. Okay, and so that's why we like, well, it's one of the reasons we like this reduced row echelon form. But that is our reduced row echelon form, and so we'll call this video done.